Recording. Okay, so today we're going to be covering the rest of 7.5, which deals with graphing, and then 7.6, which is dealing with inequalities. So that is the goal for today. Keep in mind that our exam for announcements here. Oh gosh. Okay, so the announcements is exam 4. Is this Friday? I'm trouble right with this thing. Exam 4. It'll be open from Friday at 8 a.m. to Saturday at 8 p.m. Again, that's on Alex. You can see it from your screen there. If you go onto Alex, it should be on your calendar, or at least saying upcoming. A couple things that I did was I've made a review for exam 4, and that can be found on Alex or on Blackboard. So it's generated through Alex, but you can find a PDF version on Blackboard if you'd rather work it out on paper. Same type of question, same length. It's just on Alex, the review, you have unlimited attempts, and it'll show you kind of like step by step of like, if you did something wrong or if you need extra help with that. So that's available until the start of the exam. So this is, I just kind of guess when I think that's how you spell available. Or I should just say closes at 8 a.m. Friday. So it's not available, while the exam is being taken. Okay, lastly, Thursday is review. So we're covering the last material today, and then I'll have office hours Thursday, and then all of class will be review. So I can work through any of the questions that people have on the review Thursday. Are there any questions so far about what this says? Seem okay? It'll be similar to the last exam. There are 24 questions on the exam. Okay, so real quick, I wanted to show you where you can find the review on Alex. It's right here. You go to assignments, like you were going to look up your daily work here if you wanted to. It's under exam 4 material. And then it's right here. So at the very top, at least it should be on the top for you guys too. All right, and then here's all the other daily works that we've had this semester, including the one we're doing today, which hasn't appeared yet. It'll upload at 8:30. But yeah, this is where you can find it. Go to assignments and it's exam 4 review. And so if you click it, it looks like this. So the questions are really similar. You don't have a whole lot of room to work it out on the PDF, but if you go on to Alex, it'll look just like the test, right? Because it'll be online. And then it also includes the answer key down here at the bottom. So you can check your work through that. And then on Thursday, we can work problems from this or any other questions you'll have.
Did you say that was daily work or the review?
This is the review.
Did you say the daily work was on there too? Because I did my daily work on Alex.
Oh, yeah. So just remember that there are 2 options for daily work. You can do it on
okay.
Alex or you can submit it by paper. So if you wanted to review, you could always go here and download the PDF if you wanted to do that, but it's here for you. So any other questions? Okay, so let's go ahead and switch back over here and we'll go ahead and get started. Are there any questions before we get going? I pull up the chat here. Okay, so we ended with section 7.5. That is looking at a vertex of a parabola, which the parabola is just the graph of a quadratic function or equation. So just, kind of redefining things here. Well, I guess we define it down below. So we'll not define vertex right here, but let's look at parabola, right? So parabola is the valley or hill looking shape of a graph, right? So well, hold on, let's, it looks something like that. It could be opening down or it could be opening up. And it's the graph of a quadratic equation or function. So that is what a parabola is, and so we're going to do just a couple more things in section 7.5 that we didn't get to yesterday. Again, if you want some review on that, it's from last lecture. You can go and kind of see what all this is here. But we had this last time. This is just a review. The vertex is HK, so this is called the vertex form of a quadratic. And it's really nice, right? Because it tells us what H and K are. H and K are the vertex. The vertex is either the bottom of the valley or the top of the hill, right? So the vertex is really important, and it makes graphing a little bit easier knowing where that is, because you have this line of symmetry, which is why the vertex is so nice to find, right? So this line of symmetry just cuts right down here through the vertex, right? If you were to fold it over, think about folding a piece of paper, you'd have the left and right side being the same, right? The parabola is symmetric. So that is what that is referring to. That's why the vertex is really important to find. Yeah, and that's just kind of a quick review of those, right? A telling you whether it's opening up or down, right? If A is positive, then you're going to have this sort of graph. If A is negative, then you'll have that sort of graph. Okay, moving on. We had the vertex form. The vertex form, we had a formula that basically gave us the vertex if we were given a parabola or a quadratic equation that looked like y, well, I guess it's in function form, so we'll do that. So f of x is equal to x squared plus 2x plus 1, right? So notice this isn't in vertex form, but we can use the vertex formula to help us out. I scribbled this one out because I don't like it very much. It's this one right here that I think is super nice. Okay, so remember we're trying to find h and k. That is our vertex. So I'm just going to do some different colors here. Later on, we won't spend as much time, or I won't go into all the coloring like I'm doing now, but I think it's good practice. So h and k. So again, we can use this right here, that equation or the formula, and we get h is equal to b over 2a, negative b over 2a. So plugging those values in, right? Remember, we're looking for our coefficients, which is the number in front of these x values and this constant term here, right? This is a, b, and c. So plugging those in, we have, now I'll go down like this. All right, the opposite of b, which is 2, so negative 2. 2 drops down, then a is 1. So this is negative 2 over 2, or negative 1. So what this tells us is our x value for our vertex is negative 1. Again, this formula is really important, and we'll use it quite a bit today, and we used it yesterday too. So just be familiar with it, know where to find it if you need to recall it. Okay, now we've got f of negative 1. So what this is saying is you plug h, which is an x value, but plug h into equation or function to find k, right? So once you have the x value, right, because remember the vertex is a point, right? So this is our x value, this is our y value, right? So if you have x, you plug it in to get y. If you know what your x value for your vertex is, which is represented by h, you can plug it back in to find k. So you get negative. Oh, you got 1 times -1 squared plus 2 times -1 plus 1. Right? So we can work this down. -1 squared is +1. Oh, times this would be a -2, +1. All right, so you get 1 minus 2. What is this? This is -1 plus 1. So this is 0. So we have 0 is our vertex point there for our y value. Okay, so that's using the vertex formula. We're going to see that down here for this type of problem. So we're still in section 7.3, which is dealing with this down here, or excuse me, we're still in section 7.5, which is dealing with the vertex. So this type of problem wants us to find the vertex and the x-intercepts, or the intercepts. Okay, that wasn't working. All right, yeah, so let's look at what we need to do. So use the vertex formula to find the vertex. So that is what A is talking about. I think the best way we could organize this is just separate it like this. Okay, so A, we're going to use H is equal to -b over 2A, right? And then K is H. Oh, hold on. Kind of confusing because we've got H of X and H. So let's change this to f of x, just for simplicity. I don't want to have h in both places. So that means f of h is going to equal k, right? That is what we're going to use to find the vertex here. So if we have f of x is equal to x squared minus 2x plus 5, plugging those values in to find h, kind of draw a line like that. We've got -b over 2a. Again, you can label what your A, B, and C are. Now you're not using C here, but you can still label it. What do we get here? We get the opposite of -2, right? Plugging in -2 here for B, and then 2 times A, which is just 1. So simplifying this down, the opposite of -2 is 2, divided by 2, which is also 1. Okay, so we've got 1. Yeah, so we can plug that back in and find K, which would find our vertex for us. So substituting this in, we have f of 1, which is what we found, and we're plugging it in to this function here, f, right? So f of 1, you've got 1 squared minus 2 times 1 plus 5. So substituting the values in, everywhere we see an x, we get 1 minus 2 plus 5, which is what? -1 plus 5, which is +4. So that means our vertex is the point 1, 4, which is the answer for B. Are there any questions over this first step here? Okay. If we look at B, we need to find the x-intercepts and y-intercepts. Okay, so let's look at the, let's go x-intercepts first. Right, with the x-intercepts, we're looking for where the graph is going to cross the x-axis, which means that y is equal to 0, right? So with an x-intercept, y is equal to 0. Okay, so plug this in, right? We're looking at our function, so we have f of x is equal to x squared minus 2x plus 5. Remember that y and f of x mean the same thing, right? F of x is just saying this is your output, which is the same thing that y is saying. So what we have here is 0 is equal to x squared minus 2x plus 5. We're plugging in 0 here. Now we need to factor this, right? So again, factoring would give us x and x. What do we got here? Would be, was it -5 plus, oh, hold on, is this going to be a complex one? Can we not factor it? Let's see. I don't know, are you guys getting any option to factor here? What do we think? I don't think we can factor this like this. Like, so this method won't work, right? You can check, but there shouldn't be any way. So when something like that happens, where you're not able to factor it this, like factor it over the real values, when in doubt, use the quadratic formula, right? So that means we can use the QF, which is quadratic formula. So that's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so again, we can label each one of these. All right, this is A, B, and C. So when we substitute these values in, we're going to get 2 plus or minus, now square this to give you 4. Now 4ac, I never like to skip on this step, so I'll just write all that out like that. Divided by 2 times 1, which is A. Okay, so you get 2 plus or minus the square root. Now here, let me highlight it. Right, this right here is going to equal 4 minus 20, right? So here we got negative 16 divided by 2. Oh, okay, so we get 2 plus or minus. The square root of negative 16 is imaginary, so we have 4i divided by 2. Now we could probably simplify a little bit further. And to do that, you could separate these into x equals 2 over 2 plus 4i over 2, so separating the fraction. And x is equal to 2 over 2 minus 4i over 2, right? So then this is equal to 1 plus 2i, and this here is 1 minus 2i. So here are your x-intercepts, or you could write them as points if you wanted to do that as well. But yeah, that is using your quadratic one here, right? So it would be like 1 plus 2i. That would be another way to write it. Okay, let's look at the y-intercept. Okay, so the y-intercept is similar, where if we want to find the y-intercept of this graph, that means that we're automatically given that x equals 0. So calling back to the beginning of the semester where we talked about x and y-intercepts, all right, you can think of it as a point. In this case, there's 2 points, but you're looking for the x-intercept. Y is 0. Here, the other way around. So given this function that we have, when we plug in 0, we have f of 0 here. So 0 squared minus 2 times 0 plus 5, that just kind of gets rid of everything there, and we have 5. So f of 0 is 5, which means our y-intercept is 5, or 0, 5. Okay, so there's your y-intercept. And these are your x-intercepts down here. You could circle that one there. Are there any questions over finding the intercepts? Well, we're going to have another example down here. So if you have any immediate questions, let me know. Okay, the third one was sketch the function. Now, this is just kind of a review from yesterday, which I know I said to go back and look, but I don't know. I think it'd be good to do this. So we've got f of x is equal to x squared minus 2x plus 5. Again, that is what we started with. up here. Okay, if we want to sketch this function, what we can do is make a t-chart, right? So here we have our coordinate plane. Draw some lines here to separate it. Okay, so let's make a t-chart. Right, you've got x and f of x or y, and to fill this in, we want to put the vertex in here. Right, so the vertex is going to be your starting point. It just allows us to not have to find too many points, right? If we know the vertex. Well, all this work here was finding the vertex. So we can put in 1, 5, or 1, 4, I think is what the vertex was. Yep, 1, 4. And that means we can find a point less than this, which is 0, and -1, and 2, and 3, right? So looking here, you can find one that's less, or subtract one again, and then add one and add another. Okay, the reason that we find the vertex again is we're here at 1. So 1, 2, 3, 4. Right? Remember the vertex is symmetric. Wow, that was really bad. Let me try that again. I'm sure there's a way to draw a straight line on here. Okay, so if it's symmetric, that means that we only need to really focus on one side of the parabola, right? That means uh, we're looking at the values of 0, -1, 2, and 3, right? So if you find just the values for one side, you automatically have the values for the right side because they're symmetric. So that means I'm only going to look at x is equal to -1 and x is equal to 0 because those numbers are just a little bit smaller to work with. Okay, so with x equal to -1, we can plug this into our function. So f of -1 is equal to -1 squared minus 2 times -1 plus 5. Okay, this is 1, 4, and 5. Again, just evaluating those using order of operations. What do we have here? We've got 5 and 5 to 10. So what we have here is this is 10, thank you, and this is 10. Right, again, because it's symmetric, we already know those values. Okay, so my goodness, so 1, 2, 3, 4, 5, 6, 7. Oh, good. Boy, look how much that enhanced the picture. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, that's 10. If you're ever drawing a diagram, just label the point that you're trying to get to, even if your notches are all weird. If you label the point, then people know where you're going to when you're graphing it. So I messed up on purpose so you guys can see that. Right, so this is 10 up here. Okay, so 3 and -1 are up at 10. Now we need to go ahead and do the same thing for either x is equal to 0 or x is equal to 2. Personally, I think x is equal to 0 will be much better. I'm going to separate these with boxes. Okay, so x is equal to 0. I'll move down just a little bit. We've got f of 0 is equal to 0 squared minus 2 times 0 plus 5. Notice it clears everything but the 5, so we just get 5, which means we get 5 here and 5 there. So again, going back up here, 1, 2, 3, 4, 5 is about right there. So we've got 1 there, 1 there. And there's what our function looks like, graphed. So there's the sketch of the graph. So that's a bit of a review from yesterday, but it's still important, right? It's being able to find your intercepts and the vertex. Are there any questions over this example? Okay, well, this is what the daily work problem will look like. It's similar to the one up above, It's just it's worded differently and set up a little bit differently. Okay, it looks like I wrote this a little too large. Okay, so we want to be able to find the x-intercepts and the, it looks like we only want the x-intercepts here, and the coordinates for the vertex of the parabola given by this equation here. Okay, so again, we can separate these into two problems, right? So this time, let's find the x-intercepts first. So remember with x-intercepts, right, there's s, we might just have one, that y is going to equal 0, right? We know that if we want to find the x-intercepts, y is 0, and then it's vice versa for the other one here. So we've got 0 equal to, oops, we've got 0 equal to, let's write it like this. So we've got 0 equal to x squared plus 2x minus 24. Okay. Again, to solve these, you need to factor, right? So if you want to solve a quadratic, you have to factor. Hopefully, we can factor it this way. You notice that if I couldn't factor it this way, I use the quadratic formula. You can always use the quadratic formula. It will always work. It's just creature of habit. I try to factor, usually guess or check, and then if that doesn't work, I very angrily use the quadratic formula because of all the work that I put into this. Okay, hopefully we see that this is going to be, what, positive 6? Oh, you guys are quick. Thank you. Right. It gives us this 2 here. Multiply those together. Good. Okay, so we now solve this, right? So use the zero product property. So we have this equal to 0, and the next one equal to 0, two factors. So what? Negative 6 and 4. So your y-intercepts, or excuse me, your x-intercepts are these. Or you could write them out as points, right? So negative 6, 0, or 4, 0. So this is where the graph is going to cross the x-axis, or at these 2 points. Okay, the second one is finding the vertex. And then you'll find the vertex here. Again, it's for y equals x squared plus 2x minus 24. Notice this is in standard form, right? This is a standard form of a quadratic. So if it's in standard form, we're going to use this h equals negative b over 2a, and then f of h equals k. Again, we're not in function notation, but remember, if we just find h, we plug it back in and automatically get k. So that is what we're going to do here, right? We're looking for these special points h and k. Okay, so here we're going to use h is equal to negative b over 2a. Again, it's always good to label your coefficients. So a, b, and c. Setting that equal there. What do we have here? Negative 2 divided by 2 times 1. Man, we are on a roll for getting 1 and negative 1. So see that's negative 2. 2 times 1, so we get negative 1 when we work that out. Okay, now once we have the h value for our vertex, which is negative 1, we need to find k. To do that, we plug in our value for x, or the h value, right? Remember that this is x and y, right? It's a coordinate, x and y. Okay, so we find x, plug it back in, or we found x, so we plug it back in to find y. All right, so plugging this in here, we get 1 plus 2 minus 24. What do we get here? So this is 3 minus 24, negative 21. Okay, so using that, we found that this is our vertex here, right? So again, if you find your h value, you can plug those in and find the other ones here. So let me clean this up a little bit. Are there any questions over this type of problem? Again, using the vertex formula is super important, so make sure you have that handy and know that you use it when you have the standard form of a quadratic, right? Okay, now we talked about this one, right? I mentioned this up above, and the reason being is for this question here, which is your fifth or your second type of daily work problem, given this function here, uh, when does the function reach its min or max value? What does the min or max value occur? So this is saying when, this is looking for the y value, right? And this is looking for the x value of that. And what is the function's min or max value? Oh, hold on. I got that mixed up. This is y. So this is either, right? Min or max. So you got to figure out which one of these this equals, right? And this is just the y value. Okay, well notice that when it's asking for min or max value, what we're looking for is the vertex. So we need to find the vertex for this problem, right? This problem requires us finding the vertex of this quadratic down here. Now again, it's in the standard form, so we're going to have to use the vertex formula to do that, right? Again, yeah, be aware that it's one of these two cases, right? So once we find the vertex, and then hopefully we'll be able to know. Now, notice that it's going to be a minimum value, right? If the vertex is opening up, right? If it looks like this case here. Well, notice that it only opens up whenever a is bigger than 0. Let's use a different color. Whenever a is bigger than 0. It's a maximum value. It's a maximum value if a is less than 0, right? Because that means it's opening down. That means it's the top of the hill and not the bottom of a valley. Okay, so to help us out here, let's scroll down just a little bit. What is our a value here? Does anyone know? So be looking at it. Like, what do you think your a value is here? Perfect, -3, right? Remember that this is the standard form of a quadratic, right? So this is a, b, and c. So what we're looking at is -3. Now, what is that even telling us? Well, remember that if a is negative, that means our parabola is going to be opening down, right? So our parabola is going to look like this. And this right here helps us solve our first question, which is, does the function have a min or max value? Well, it's going to have a max value because a is less than 0, or you have this downwards parabola, right? Okay, so to find the value now of this min, of this maximum, we need to go ahead and find the vertex. So we're going to use -b over 2a. So again, -6 divided by 2 times -3, right? Plug those values in. What are we going to get here? Just a little bit. Did we get -1? I agree. Gosh, we have gotten a 1 for all of these vertexes. That's good stuff. I just chose, I mean, chose these problems from Alex. So, all right, so we get 1 again. And now again, we're going to use this and the fact that k is equal to f of h, right? So now we plug in our value here to find k. So now we're going to use f of 1, so substituting that value in. So -3 times 1 squared plus 6 times -1 minus -6, right? Again, oh, did I switch signs? Yeah, got ahead of myself there. It's a positive 1, right? That's coming from h being 1, right? That is where the 1 is coming from. Okay, what do we get here? -3 plus 6 minus 6, so -3 is what we'll find here. So what we're looking at here is our vertex is 1, -3. And so what is this meaning for the answers here? Well, what is the x value for the maximum point, right? It's going to be 1, right? That means the largest value for x is going to be 1. And then it just, or, yeah, where the maximum value x is 1. Y is -3, right? Again, just this is an x and y point, right? So that there is how you do the second type of problem. Now this is finishing section 7.5, which is again dealing with graphing. Are there any questions? Okay, we're going to go ahead and move on. Now this is 7.6, which is polynomial and rational inequalities. Okay, so to review, inequalities are dealing with less than, greater than, and then the same with or equal to. So we've got less than, in greater than, less than, right? So less than is this way, greater than is that way. And then you could have the or equal to, right? This is equal to. So just reviewing those are our inequalities. So we're going to be solving, looking for sets of solutions for these inequalities. Okay, so the graph or quadratic inequalities are inequalities that can be written in the following, right? So again, in this example here, these are all standard form of quadratic. So I don't know where I want to write that. Yeah, but these are a standard form, right? ax squared plus bx plus c. Right, a can't be 0 just because then it would become bx plus c, right? And then it's a linear function, but regardless, that's what it looks like. Okay, so the graph of a quadratic function, which is given by this, so now we're changing to a function, which, is an equation here, got an equal sign, is a parabola, which means that we're either opening up or we're opening down. So what that means is if we know, I don't know what I did with, oh, it's down there. So that means that the inequality, if we're looking at, this being greater than 0, then the values of x that make it true is above the x-axis, right? And then the inequalities, when it's less than 0, means it's below or negative. And so you can answer these questions by looking at it graphically. So what we're going to do is the first thing is solving these graphically, and I think this should make a little more sense. I was going to go with kind of a rough example, but I think by looking at an example, it'll make that a little more clear. Okay, so let's use the graph of this to help us solve these inequalities. Okay, so again, we need to graph x squared minus 6x plus 5. So we'll do some scratch work here. Right, we want to graph x squared. Let's put that function notation in there. Right, we want to graph this here. Okay, so again, to graph, right, we're going to have an x and an f of x. We have to figure out what starting point we should have. Now, while I get this drawn, do we remember what the starting point is? Like, what should I find first to help us figure this out? This is a bit of a review. Okay, what we're going to do is we're going to find the vertex. Good, right? The vertex is going to give us this symmetry. So again, to find the vertex, we're going to use h is equal to negative b over 2a, right? So plugging in our values there, move this down to over here. And I think what I'm going to do is move everything down here just a little bit more. Right, so we're going to use the vertex. I'm going to draw it right here. Hopefully, you're going to see whenever we find this solution that graphing it is probably the most time-consuming part of solving this problem. Once you graph it, then this part here is pretty straightforward. Okay, so here we are, plugging these values in. I'm unintentionally stalling. Okay, there we are. All right, so negative b, that's going to be the opposite of negative 6, divided by 2 times 1, which is what, 3? Right, and work that out, you get 3. So then f of 3, right, we got to plug f back into this function here. I don't think there's any way for me to vertically shift this over. So plug in 3 to your function and see what you get while I try to get this to give me the right size here. Okay, so f of 3, right, we're going to have 3 squared minus 6 times 3 plus 5. When you plug those in, you get 9 minus 18 plus 5. 9 minus 18 is negative 9 plus 5 still, which gives you negative 4. So your vertex is 3, negative 4. I'll write this here. So we get 3, negative 4, right, for this graph here, or for this function. Okay, so what we have is 3, negative 4. So it means we already have a point that we need. Where are we at here? 3, negative 4, so 1, 2, 3, down to negative 4, so we're there, right? Okay, again, the vertex is super nice because now we only need to find points on one of the sides of this line of symmetry, right? So again, we got 2, 1, 4, and 5, right? I'm picking the points symmetrically. Right, so if we plug in 1, I'm not gonna, just for the sake of space, if I plug in 1, I get 1 minus 6, which is negative 5, plus 5 is 0. Now, did I do that correctly? 1, negative 5, okay, 0. So that means we get 0 for 1 and 5. So for 1, y is 0, which means it's right there on the line. So 1, 2, 3, 4, 5, and that means 5, it's also on the line. Right? Okay, what else do we need? We need 2. So plugging in 2 here, it's going to be 2 squared. Well, how about this? We'll erase this here. All right, well, what is that going to equal? Well, 2 squared is 4 minus 12 plus 5. This right here is negative 8 plus 5 is going to give us negative 3. So we find negative 3, negative 3. Right? So plugging those values in, we can plot it. Now, once everything is graphed here, so 2, negative 3, so about right here, negative 3, we get a graph that looks like this. Okay, now all of this work is helping us to solve these two questions. So the first one is, and what I'm going to do is write this in different colors so we can see. So x squared minus 6x plus 5 is less than 0. The other one is going to be x squared minus 6x plus 5, but this time we're looking for when it's greater than 0, right? So the question is, yeah, what x values make this true? Well, looking at the first one, when it's less than 0, the question is, when is this function less than 0, right? When are my outputs negative, essentially, which is what this is talking about up here, right? Whenever it's less than 0, it's for the values of x where the function is negative or below the x-axis, right? So when this is less than 0, what we're looking at are all the numbers here, right? Now we're not including these points, right? So there'd be circles there because it's not or equal to, right? So we don't want to know when it's equal to 0, just less than 0. right? So that's one way you can write your solution, right? You can shade it on your graph. Or in interval notation, which is what IN will stand for, that's just the points between these here, right? So what we're doing is we're looking between points between 1 and 5. Now, how did I get that? Well, remember that our y-intercepts or excuse me, our x-intercepts are 1, right? 1 and 5. So we're looking at everywhere between those points, right? That's where the graph falls below the x-axis. Okay, now we can look about when it's greater than 0. Well, when it's greater than 0, it's the other side, right? It's whenever these values go up. You can think of, right? These are our positive outputs. These are our negative outputs. So when it's greater than 0 or we have positive outputs, we would shade it here, right? So there's what your solution would look like there. Now, you can also write it in interval notation. Interval notation is going to look like this, right? Be thinking of like, it's just going up here, right, from 1. So in interval notation, our first one here is going to be from 1, right? Not including the endpoint again, because it's not or equal to, and it's negative infinity, right? So that deals with this side. The other side, right, we're going to union it because we're looking here, is going to be from 5 to infinity, right? These are all of the x values that make this true, make it greater than 0. Okay, so if you're sitting there thinking, well, that is really complicated and I don't like graphing, that's okay, because there's a second method that we're going to use that will also give us the solution without us graphing it. So let's look at the next method. The next method is solving these inequalities using the point or the test point method, where you're going to find the boundary points of the inequality. Now, the example of this is you're going to basically factor, right? You want to know when is y equal to 0. This is going to give you your boundary points. I didn't like the definition they gave. Your boundary points are what does x equal when y is equal to 0? Do we have a question? I'll go ahead and mute everyone. So again, I muted everyone. You can use the chat or turn on your mic. You can ask a question. So we just talked about graphing one, but here, solving these inequalities not by graphing, but by looking at points, right? This is called the test point method. So when it's saying boundary points, that means we want to set it equal to 0 and see what values make it equal to 0. So that is what the boundary point is talking about. I don't know why I do that. I'll just quick drag down that. Okay, plot 2, or step 2. Plot the boundary points on the number line. So this will divide it into segments, right? So that is number 2. Now, hopefully, this is bringing back some good memories of solving problems like this, right? So you solve your boundary points. Let's say x is equal to 1 and 3. That means, well, let's make a negative number. Let's say negative 1 and 3. Right? Step 2 is saying, well, it's going to divide it into sections, right? You're going to have negative 1, 0 for a reference, and 3. Right? That is what step 2 is talking about. Right, divides it into sections, which we just saw. Step 3 is you want to select a point from each interval and substitute that back into your inequality. So let's say that our inequality is x squared plus 2 minus, okay, so it'd be minus 3. Okay, hold on, I'm making that way more complicated. X plus 1, x minus 3. Let's go less than 0. Right, so notice that this gives me my boundary points. So I just chose the boundary points that I have here. right? So then the next part is saying that you can test points, right? Because our goal is to figure out, where is this true? Is it true here? So we've got true, false here, true, false there, true, false here, right? So we've got 3 segments we have to choose, and we pick a point in each of these intervals. So for example, here you could pick the point -2. Here I would choose the point 0 because that's just a nice point to pick. Here you can choose the point 4, right? And so that is what step 3 is talking about. Now, step 4 is talking about you want to test these points, and it'll figure out where it's true or false. So I guess we could do, if we wanted to label each of these steps, it's not that, well, we're going to look at an example. But just describing what this is talking about, step 4 is referring to testing the points in the inequality. So that means if we want to test -2, right, that means we would go up here and we would test it into this inequality, right? So plugging in x is equal to -2, we want to see, is this true, right? Well, -2 plus 1 is -1. Here, -2 minus 3, so we're going more negative. I guess more negative. So you get -5, right? Is that less than 0? Well, these two multiplied together give you a +5, which is not less than or equal to 0. So that means it's false here. Testing 0, which is our next point we can test, right? Well, is that going to give us a solution? Oh gosh. What do we think here? If we plug in 0, is it true or false? Kind of asking this for everyone in the chat, but also while I try to sit here and plug everything in. Okay, so you plug in 0 plus 1, 0 minus 3, right? So plugging these values in, you want to know, are those less than 0? Well, this gives you 1, -3, right? Is that less than 0? Well, this gives you -3, which is indeed less than 0, right? So it is true there, right? This is true, that was false. Okay, so this is true there. Again, you can test the last one. It will not be true. But we can test it just to make sure that I'm correct and I'm not leading you all astray. I hit training. I don't want to do that. Right. Just copy and paste that there. Okay, so this is going to be false. Now, why? Well, hold on. No, it'll be true. Right. Do everything correct here. -1, 3. That is false because you plug -2 in, you get -1. -1 is a positive. Oh, okay. Man, if I would just do the work, I would see why that's not true. Okay, so plug this value in. Don't just sit there and stare at it. So you get 5 minus 1. That is not less than 0. Right, so it's false here. Right, so your solution is in between these two. Right, it's true in between these two values, which means in interval notation, you would get -1 and 3. Again, you wouldn't include the endpoints, right? You don't include -1 and 3 because it's not or equal to. So that is why you would exclude those, right? So that would be your answer to this there, right? The values of x that make that true are in between -1 and 3. So these are the two methods to solving these. In the chat, do people prefer method 1 or method 2? Do you prefer, again, method 1 is graphing it, So this is method 1, method 2. Why I'm asking is I plan on working the next 3 examples that we'll see, which are your daily work problems. You know, either one. Is there a certain preference we'd like to see? Do you like seeing it being tested or graphed? So while you're thinking, now notice that it's actually the same kind of method that we're doing, right? That when you graph it, you're looking at a two-dimensional shape, right? You're looking at the x and the y. Here, though, you're only looking at the x-axis, right? You're only looking at one line. So both give you the same method here. Okay, so let's go start looking at examples here. So this is test. Yeah. So a lot of people don't like graphing. I really like graphing, but again, I'm not, you don't have to, there's another method for a reason here. Okay, so again, let's look at an example. This example is really similar to that example. So I think for sake of time, I'm not going to do this example because it is really, it's really loud. It is really similar to this problem down here. Okay, move this up here. Now, for these next examples here, I will use the test point. We had someone in the chat prefer that one, which is good. Like it's, yeah, but both are good methods. Okay, so if I wanted to test this point, really the methods are pretty much the same. Well, we use method 1 with this problem. We'll use method 2 here. So method 1, excuse me, method 2, right? It's the one we just did up above. Now we want to graph the solution of the following inequality on a number line. So here, the first thing we need to figure out is what are our boundary points? What are our boundary points? And now really what we're asking with boundary points is when does x minus 3 times x plus 4 equal to 0? Right? We want to know what values first, because basically we have a number line. We've got a number line, and we have to figure out how do we break it up, right? How do we break up our segments? Now we're going to do that by solving this first, right? So x minus 3 equal to 0. Let's not write it with parentheses. X minus 3 equal to 0. X plus 4 equal to 0. Means x is equal to 3 and x is equal to negative 4, right? So these are our points that we're going to put on our number line. So we've got negative 4, positive 3, and we've got 0 in here for reference, right? So really what we're looking at here, just to drive this home, these are our reference points, our boundary points, right? It's going to be the boundary of our intervals. Because now what we want to do is we want to look, when is it true or false here? When is it true or false there? And when is it true or false here, right? This is going to help us figure out where we're going to shade, right? Where is our solution at? Okay, now we pick a point. We can pick a point in this interval here. You can think of the interval going to infinity, right? It's just going all the way out here, right? So there's your first interval. Next one's in between those two, and this one is to positive infinity. Okay, now you can pick a super large number, right? For example, let's say I wanted to choose negative 1,000. Well, why the heck would I want to do that? Well, think, if I subtract negative 3 from negative 1,000, is it still going to be positive or negative? Well, it's still going to be negative, right? Because negative 1,000 is huge. Now, if I'm going to plug negative 1,000 into here, well, negative 1,000 plus 4 is still negative. So when you multiply negative and negative, you get a positive. So it would actually be false. But again, you don't have to think of it like that, right? I like to pick really large numbers and just kind of reason it out. But we can choose negative 5, right? Let's choose a pretty small number, right? Can't choose negative 4, but we can choose negative 5. Okay, so choosing negative 5 over here, let's choose 0. Here, oh, this should be a positive 3, shouldn't it? I don't know why it's negative. Here, let's just pick 4, right? So we're picking 3 points, and now we test each of the points, right? We figure where, like, when is this true for each of those. So each one of these we're going to test. I'm going to break this up into sections. All right, so we've got this section, this one right here. This one we're going to test -5 in. Again, remember that it's x equals, right? We're testing x is equal to -5, just so we know. Test x into 0, test x is equal to 4. Now what we're doing is we're plugging in this value here, right? We're testing the main inequality. Right, so you're plugging your value into this. Okay, so plugging in -5, you got -5 minus 3, -5 plus 4, less than 0, right? Or that's a question mark, right? We don't know if that's less than 0 or not. Okay, this right here, -5 minus 3 is going to give you -8. -5 plus 4 is going to give you -1, right? We still don't know, is that less than 0? Well, multiplying two negatives is going to give us a +8. Right? That is not less than that, right? That's false. Trying to find the erase button. Right? This is false. Okay, which means we're a third of the way there. We need to do the same thing for the other 2 points. So x equal to 0. Again, right there. Barely fits. Okay, plugging that in, we get 0 minus 3, 0 plus 4, right? Question, is that less than or equal to 0? Okay, this gives us -3 times 4, right? Is that less than 0? Well, we have a negative times a positive, which is -12. That is less than or equal to 0. So this is true. Okay, so we're true here. Now this is going to be false. Again, you'll start seeing the pattern over and over again. Like if you've got the in-between, then, well, that's not necessarily true. There's kind of a pattern here with it. For example, they all could be true. They could all be false. Or you have true, false, true, or false, true, false. So those are your only options. Again, I'm not going to write that down. I don't want to confuse everybody, but there is a certain, pattern there with it. I might explain it here at the end if anybody would like to know the pattern and why that's true. So keep that in mind. If you want to learn the pattern, stay till the end of the video. Like, share, and subscribe. Okay, so plugging in 4, 4 plus 4. Again, we want to know, is this less than or equal to 0? This is negative, oh gosh, did it again. This is 1, this is 8, right? Is that less than or equal to 0? Well, no, because this time we got the same thing, right? Not true, so this is false. So graph the solutions to the following inequality on the number line. Well, true, false, true, or false, true, false, right? It's true in the middle. That means our solution is going to be here. Oh gosh, I meant green. So you want to go ahead and graph that on your number line. I'm trying to figure out why it's not working again. Okay. All right, so your solution's here. Now, I think for the sake of this here, let's go ahead and write in interval notation. I want you guys to know that there is a similarity between looking at the graph that we drew and then also interval notation. Now, interval notation, it's going to be between -4 and 3, but we keep the endpoints. And we're including those because it can be or equal to 0, which is why we include that. Are there questions over this problem? Okay, so that was using the second method, which is testing the points. Now here, let's graph it. So again, it says graph the solution to the inequality on the number line. Again, here it just wants you looking at a number line, but you could graph the solution, right? You could graph the line here. Okay, so regardless of what method you use, in this case we're going to use method 1. Yeah, we're going to use method 1 here. You want to set equal to 0, right? So that means solve this for 0. So add 12 on both sides. That is going to give us x squared minus 8x plus 12 less than or equal to 0, right? Now again, you can do the same thing we did up above where, you know, you factor it, look at the boundary points, and so on and so forth. Here, if we can, let's try factoring this. So similar to how we did up there, right? Let's look at, right? Let's kind of look for our boundary points. Now we're still going to do method 1, but we'll look to see if this factors to something nice, right? Question is, do we have, can this factor into anything, right? Well, let's look. 2 and 10, 1 and 2, 2 and 6. Do we get -2 and -6 is what we find? Everyone agree? So again, that means x is equal to 2, x is equal to 6, right? These are our boundary points. Well, what we have here is if we wanted to graph it, again, using method 1, that means that we're going to have 2 intercepts on the x-axis, right? That is what this told us. When we factor, we're looking for the x-intercepts, right? That is what that does when we factor. We're finding the x-intercepts or the solutions. So we have 2 here, 3, 4, 5, 6 over here. Okay, so we have intercepts. We're going to graph the parabola and then figure out the solutions based on that, right? So again, we had to get it in this form here. Okay, so now we got to figure out where's our vertex, right? Is our vertex up here or down here? So using method 2 here, let's find, we factor first. And then second, we're going to find the vertex, which is HK. Now again, it's in this x squared minus 8x plus 12, right? It's this equation, or we'll make this a function. Again, we want to find the vertex. That's going to tell us where, is it up here or down here, right? We know it's going to be in the middle because it's the vertex, but we got to figure out where. So again, h is going to equal -b over 2a. What's that going to be? Negative, or the opposite of -8 divided by 2 times 1. So we get 4. Plugging that in, we find that 4 squared minus 8 times 4 plus 12. Oh gosh. All right, what does that equal when we do that? Again, I'm just stalling while I move everything over. Okay, what does this equal? Well, 4 squared is 16 minus 32 plus 12. Again, just multiply these out. 16 minus 32, well, that's just double that. So this would be -16 plus 12. This is -4. Again, I went through the math pretty quick. We found our vertex is 4, -4. Well, why is that important? Well, it's because we now know where our graph is opening at, right? We find that we've got 4, so 1, 2, 3, 4, and we go down to -4. Right, there's our vertex. And it has to be opening up, right? We know it's opening up because A is positive, right? There's your A. It's positive 1, but it wouldn't make sense to open down because we know that there's some points up here that it crosses. Okay, so again, using method 1, we can now look at this. Okay, so all of this work has come down to us looking at when is x squared minus 8x plus 12 less than 0, right? Now again, if you're looking at your number line, really, if you drew your number line, if you're using method 1, your number line is going to look like this, right? 2 and 6 are still going to be there, right? Your number line looks like this. Notice that it's the same here, right? We're looking at a parabola. Before I get too ahead of myself, when is this less than 0? Well, it's everywhere below the x-axis. So there is our solution below here. And if you were to use method 1 or method 2, you would find that it's in between because it matches the graph up here, right? Be thinking that your x values that make it true are in between these two values. So the same is true here. So your interval notation or your solution in interval notation is going to be between 2 and 6. Now in the chat, help me out. Do we include the endpoints or not? What do we think? Or you can say if you're watching pre-recorded, pause. Do we include the endpoints? We do, because it's or equal to. So it's 2 or 6 is your solution. Okay, finally, the last problem we're going to look at for tonight is this one. So we want to solve the inequality. Now, this is not a quadratic, but a polynomial. But the method is going to be the same. Okay, for here, start with this. Right? How would we do something like this? Well, let's try getting everything to one side. Right? So that means subtract x at 3. We've got x cubed minus 3x squared is going to be less than x plus 3, and that's going to be less than or equal to 0, right? We move everything to the other side, or move everything to the other side. I think that mirrors your screen. And we want to solve this. Okay, so at this step, factor, right? So here, to do this, this is the solution, right? Let's factor by grouping. So that means we bunch this up together, and well, hold on. Let's recopy this down. So factor by grouping, right? What can we factor out here? What is our GCF? Well, that's going to be x squared, right? There's an x squared into both of these. That's an x cubed. Okay, and then here, what's something we can factor? Oh, hold on. Goodness, I'm ahead of myself. All right, let's go down one more line. Right, so looking at what we can factor out here, it's an x squared. That's going to give us x minus 3. So to match this term, we factor out a -1, which gives us an x minus 3 here, which means this factors to x squared minus 1 times x minus 3. Continuing on, again, this is just reviewing factoring. We can actually factor x squared minus 1, right? Now, this factors, let's use yellow. This right here is going to factor, because it's a perfect square trinomial, is going to factor to x plus 1, x minus 1. Again, there's a couple different ways that you can go about figuring this out. But anytime you see a quadratic, something squared, see if you can factor it down more, right? You might be able to just plain factor like this, or you might have to use the quadratic formula to find the roots or the solutions or the zeros, all the same. Okay, we are down to here now, right? We factored this into these two here. Okay, so what do we do now? Well, now it's just like we did up above, right? Now, granted, method one might not work too well because we've never graphed a cubic polynomial before, but we can use the test point method. So let's use, not moth, let's use method two up above, right? So using method two, we need to first find out our boundary points. Right, now our boundary points, let me go down just a little bit here, right, are the values in which this is going to be 0, right? So what that means is our boundary points is when x plus 1 is when x plus 1, x minus 1, x minus 3, when this right here is equal to 0, right? So our boundary points are going to be -1, 1, and 3, right? Again, use the zero product property. That is how you find them. Okay, so now we plot our boundary points, which I'll go ahead and mark in orange. Okay, so that means we've got -1, 1, and 3. And just like before, now we just have more intervals to look at, right? We've got 1, 2, 3, and 4 intervals that we need to look at here. Okay, so again, this can be true or false, true or false, true or false, true or false. So again, we're looking at each one of these intervals. So we pick a number here. So let's pick -2. We're gonna pick -2 to test it in this interval. Again, the interval is -infinity, right? Infinity. So here are our intervals. I used blue, didn't I? Okay, so in between here we've got 0. I always choose 0 if that's an option. Here, let's choose 2. And for this one here, we'll choose 4. Okay, so to find the solutions, we need to check every single one of these points into our main inequality. So we've got 4 sections, right? So all right, so let's test. Oh, I guess I'm using blue. So I'm going to test x is equal to -2. I'm going to test x is equal to 0, x is equal to 2, and x is equal to 4. Again, we're plugging each of these values into this this inequality here. Now, I am not a huge fan of having these inequalities on both sides. I think it can be overly complicated, but we can use this inequality, right? The one that we simplified down to. I like this one because we don't have to cube anything, we don't have to square anything. We can use this. So keep in mind that this one here, this is equal to that, right? These two are the same, right? And so is this one up here. So when I'm testing my points, I like to use the factored one. I think that the factored one is so much nicer. So let's use that real quick. All right, so x plus 1, x minus 1, x minus 3. We want to know if that's less than 0, right? So plugging each of these in, you get -2 plus 1, -2 minus 1, -2 minus 3, right? Is that less than or equal to 0? Well, this right here gives us -1, -3, -5. Again, we don't know if that's less than 0. Well, this gives you a +3 times a -5. Hopefully this time you're screaming at your computer saying, it's negative, it's true, right? Because it is. -15 is less than that, so we have true. All right, so this one is true. Now we have to check to see if this one is true. Again, plugging 0 into this, we can work this out and see. Just lazy, I don't want to rewrite it, so I'm trying to use my snip tool here. All right, and I left off 0. That's okay, easy fix. All right, so plugging in 0, 0 plus 1, 0 minus 1, 0 minus 3, less than or equal to 0. All right, so we got 1 times -1 times -3 less than 0. All right, so this is -1 times 1, which is -1 times -3, right? What are we going to get here? Well, -1, negative times a negative is going to give us a positive, in this case a +3. That is not less than or equal to 0, so this is false. Okay, so it's false in between here. So we're moving right along. We have our second segment here. Let's go ahead and copy and paste it. Not there, though. About right there. Again, now we're testing 2. I haven't used different colors. I hope everybody is following along with where, what we're plugging in here. All right, so plugging this in, we get 3, 1, -1, again, less than or equal to 0. Okay, so here, this is going to be 3, multiplying 3 and 1. Now 3 times -1 is -3, which is less than 0, right? So this is true, right? So plugging those values in is how we get those. So this is now true, so it's true here. Finally, the last one, we are going to check when x is equal to 4. Oh gosh, I'm kind of off the screen here. Again, here we are. I don't know how I got it to, trying to get it to scoot over a little bit more. Okay, perfect. 0. I don't know why. I would just leave it. Okay, so plugging this in, we've got 4 plus 1, 4 minus 1, 4 minus 3. When is that less than or equal to 0? Is that true? We've got 5 times 4 times 1, right? Less than or equal to 0, right? So 5 times 4 times 1. Notice that all of these are positive. So we're going to get 20 less than or equal to 0. That is not true, so it is false here. False. Okay, so now we shade right where our solutions are at. Again, I'm going to use green. It's true in this area here, right? There's one of our solutions. It's false there, but then true in between here. Okay, now we can list this out. So this part of the segment here, where it's true, is going to be from -infinity, right? This is an interval notation. -infinity to -1. Now we are going to include the endpoint, right? Because it is less than or equal to. So that is why we include the endpoint. We're going to union that because we have, oh, I'm still on highlighter, because we have another section that it's true in, right? So we need to union that. And this time we're going to include our endpoint of 1 and our boundary point here of 3, right? So our 2 boundary points. And this right here is your solution set for that, right? Or the shaded number line, whatever it is asking for. Okay, and that finishes the last type of examples here for this lesson. Are there any questions? Okay, so class is done. Let me know if there are any questions that you have. If not, we'll close this down and I'll get it uploaded. Remember that our exam is Friday and Saturday, and then the review is currently open, so you can go and check that. For Thursday's class, we are going to meet up. I'll just be sitting here, and you can ask me any questions off the review or any other thing that you have, and I can, get those worked there. I'm going to stop the recording.